See that, Paul?
That's really nice. Impressed.
Hey, y'all. Welcome to the Common Good Podcast. March 15th, Science Day, even though it's Friday around here, and for us, normally we're talking science on Thursday. We're going to leave Friday to NPR, their own.
Yeah, we try not to step on their Science Friday toes, but today is an exception.
The whole week has been a day off for us here in the rhythm. So if you really are keeping track of what days we talk about what topics on the Common Good Podcast, well, you should probably find another hobby.
Yeah.
Is your current hobby keeping up with us? Today is Science on Friday with astrophysicist Paul Wallace, and back in command central, Daniel Deitrich. And
Yay.
And folks, if you look real closely at the little name badges, if you're watching this on the video version, there's a starry background. Well done, Dan. Well done.
It's a little touch from the James Webb telescope for you.
That. Nice detail.
This is the kind of thing that keeps people interested in their jobs, right? It's just at some point your big stuff is no longer appealing, so you just
let's throw some stars on some things.
Hey, we're gonna talk
whatever it takes. Whatever it takes.
Almost this whole time here about the eclipse coming. But before we get to that, weather outside, been like 60, 65 degrees in Minneapolis, Minnesota in March. There is still no snow. We had a little dabble of snow at Valentine's Day, and then it went away a few days later. Paul, there is no snow in Minnesota.
You had none in December or November or January?
There was a little cold snap right around the time of the caucus in Iowa, whenever that was, early January. It was really cold and a little bit of snow. Then it popped back up into the 50s and has just been Kansas City around here for the winter.
So weird. It's been pretty normal around here. A little warmer than usual, but not really.
Yeah.
The Southeast has gotten, we've mentioned this before on the podcast, but the Southeast, for whatever reason, has escaped. Is one little pocket of the country that's kind of escaped this extreme stuff.
The big fluctuations, which is great for me. I mean, I'm sure there's people for whom not having snow is a real problem. You know, there's an entire snow economy here. So I'm sure there are people who are really struggling right now with, not having the snow economy going. But for the rest of us, man, this is just wearing a light jacket or sweatshirt for March in Minnesota is quite lovely. So I hope it's an anomaly.
But doesn't it bother? I mean, doesn't it bother? I mean, it would bother me. I feel like I would need my weather. I would, even if it's kind of crappy weather, I would kind of want it just to assure me that everything is normal.
Yeah, I like my seasons up here in Michigan, so I like a little snow. We got one big blizzard that really dumped like a foot of snow on us. But other than that, it's been almost nothing.
Yeah, just wild. Heard that from somebody in New Hampshire as well. And New Hampshire's had almost no snow this year, like bare grass. We have grass turning green. We have tulips popping up in Minneapolis. March.
That sounds like Atlanta. This time of year. I mean, it's it got up to high 70s yesterday, which is a little unusual. We're back down. We're going to get back down to the highs in the low 60s, which is mid 60s, which is pretty normal for March here.
The problem here is, a lot of things are starting to bud and sprout, and then if we get another last cold snap and frost, it's going to really mess up crops in the area.
That happens here almost every year.
Can do in the fruit trees, they're saying. I think a lot about people who lived in these spaces and places during times when they didn't have weather forecasting and weather details like we do, and they're just even a calendar was a little bit iffy, kind of keeping track of it, kind of general sense. And then all of a sudden there's a time like this and someone's probably arguing like, did we get our calendar off? Is it actually April? And then the thing happens that we're going to be talking about today. a solar eclipse. And Paul, in human history, this must be the kind of thing that just shakes the foundations of people's understanding of the world. When in
Yeah,
the middle, the sun goes away.
and certainly way back when it shook people, but I think that, I mean, we had it figured out a pretty long time ago what was going on. Um, like the philosophers and stuff knew what was going on. But I
But
think
did your
the
average
average
person
person probably did not. Yeah.
They're just like, God is angry at us.
What did you do, Bill? What did you do?
It was probably Bill. Yep.
It was Bill, right?
All right. So we're going to spend our entire hour talking about this total eclipse that's coming on April 8th. And
Fantastic.
the fact that there was a headline today that refers to this as the total eclipse of the Heartland is simultaneously wonderful. Just fast.
That's a great title.
Disappointed we didn't come up with that.
That is really good. We've had a lot of good headlines on this podcast, but that this is actually that's a solid gold headline.
Yeah. And the reason, folks, if you're not looking at the graphic that we have on the screen, is that the path of totality, which is also just a fantastic phrase, the path of totality for the total blackout of the sun, cuts right through the middle of Texas, up through Arkansas. Now, I think they're truly missing the true Heartland, but the pun is still well accepted. Then up portions of Illinois and Indiana, and right over parts of New York and Pennsylvania. Just incredible path for all of this. So many people in the path of totality will be captivated by this. And the rest of the country, I've come to find out, Paul, could not care any less. Like, I
they don't know what they're missing. If they just don't know. They don't understand what they're missing.
And Paul, what time of day will this happen? Like, when will it start in Eagle Pass, Texas? There,
it's going to be sometime around 1 or 2. It's middle of the day.
Okay, just
it's perfect staging. Yeah.
All right. So when we're on the Vote Common Good tour, we often say to people, we never thought we would have to travel the country saying to people of faith and conscience, you should resist insurrections and Christian nationalism is a bad thing. We thought that was a given. And never did I think we'd have to travel around and remind people, hey, faith, hope, and love should support everyone and not just the insurrectionists. But nonetheless, that's the work that we have to do. And Paul, honestly, never did I think we'd have to explain to people why a total eclipse is cool.
Well, I didn't either, but I've told you this before. I'm looking forward to seeing this eclipse as much as anything, but maybe even slightly more than that. I'm looking forward to watching you watch the eclipse. Because I know you've never seen one before.
No, when I was a kid, I don't know.
Nothing like it.
In the 70s, was there an eclipse that would have been in the Minneapolis area? Because I remember something having to poke a hole in a box and then.
Yeah, I mean, there's been solar eclipses, but there's solar eclipses and then there's total solar. They're totally different. I mean, they're just, as far as the experience goes, there is no comparison between a partial solar eclipse and a total solar eclipse.
So the one where Donald Trump stared right at the sun, that was a partial eclipse?
That was a total eclipse, but it was partial where he was.
I see.
We were all I went up to extreme northeast Georgia where it was total, and I saw it there.
Oh, nice.
Took the kids out of school, everything.
Well, as an act of recruitment and reminder, tell the good people listening here your experience and why, when we started talking about the April 8th, 2024 total eclipse, you were like, we are doing that. What kind of a thing did you experience watching an eclipse of totality?
Well, can I tell the story? Can you give me a minute to tell the story? Because it requires a little bit, just a couple minutes.
Absolutely.
I was a student at Young Harris College in North Georgia. Okay, it's a little tiny school. It was a 2-year school at the time, a 2-year private college, which is a weird thing. I started college there, and that's where I discovered astronomy. There's a planetarium, and the astronomy professor told us in 1987. He said, in 30 years from now, there's going to be a total solar eclipse, and the path of totality is going to come straight through this campus. And we all laughed because 2017 didn't even sound like a year. It was like, what's 2017? This was 1987. All years began with 19,
Mm-hmm.
and and also Saturn was in. I can't remember I'm saying Saturn was. I remember noticing where Saturn was, and Saturn has a 30-year period around the sun. So I told myself when Saturn gets back to, I think it was back to Capricorn, it's going to be time for the eclipse. That's 30 years from now, and Saturn takes 30 years to go around. And I watched Saturn go through all the signs and it returned to Capricorn. And sure enough, I was at Young Harris 30 years later to see that with my 3 kids and my wife. And it was, I really don't know exactly how to put it. It was, for me, it was the closest, it was the most memorable astronomical event of my life, without question. Without question.
Are you trying to find words to compare this so that if a family member listens, you're not saying it was greater than seeing the birth of my children? Is that where we are? Are you at that level of?
It's up there. It's
Mm-hmm.
yes, it's in the same category as that. And I think because I had it in my mind for 30 years. I mean, really, when he told us this, it made an impression on me. And I watched literally throughout my entire young adult and middle adult lives, I watched Saturn go around, and I thought about this event coming. For 30 years, I thought about it. It like fixed my calendar, and it just actually go back and to see it was incredible. Actually, what happened was the people who were on campus did not see it because a cloud came.
Honestly, that's what I'm so nervous about.
But me and my family, because I was completely intolerable to be with. I was my poor family. But we basically ended up getting in the car with 5 minutes to spare and drove north, and we saw it. We saw the actual eclipse, and the people on campus did not because there was a cloud over it.
All right, so describe what one sees when they see this eclipse.
Well, it's for the first while after this, because the sun cuts off some of the moon blocks off part of the sun, and for a long time you don't notice anything. And then when the coverage gets to be about 75% of the sun, all of a sudden the world looks like a cirrus cloud has passed over the sun. But you look up and there's no clouds. It just looks a little dimmer. Like you feel like, oh, a cloud just passed over the sun. You look up and no clouds. But then when the light begins to really fall, and it all kind of happens quickly once it begins to happen. The world changes. The light is unlike anything you've ever seen. It's not like a sunset. It's not like a sunrise. The light is completely weird. It's like all the saturation of the colors goes away, and the whole world looks like it's kind of like an old tintype photograph or something.
Really? Did you take photos during that time, or is that something?
No, I didn't. I was too fixed on what was happening in the sky, and then over the period of about 2 minutes, the temperature drops. Wow. It gets the birds, get quiet, and crickets. It fools the entire world into thinking that it's nighttime, and the light goes down and the wind picks up a little bit, and the sun itself, it's kind of hard to describe what it looks like, but when the most fantastic thing is when you can actually look at the sun without hurting yourself, and you can first glimpse the disk of the moon when the sun's corona wraps all the way around the moon, and you can first see the actual sun. And the last edge of in my memory, the last edge of the sun was almost a blue color, looked like burning phosphorus or something. and then when it goes completely out, you see the sun's corona. It's like a big hole in the sky. It's just the weirdest thing. I can't describe. You're going to see it, and you're going to love it, Dan. You're both going to just love it. I don't know Dan as well as I know Doug, but I know it's going to knock Doug out.
I probably won't be impressed.
Yeah, I'm sure you'll be just looking at your phone.
All right, so I was going to ask you that. I went to the Bruce Springsteen on Broadway event, which was spectacular. But the first hour of it, the people sitting in front of us talked the entire time and just nearly ruined it. It was something else.
Really?
Finally, people all around them had to just ask them to please stop talking. Right? It was incredible. I didn't think that could be ruined. How can someone ruin a solar eclipse? What's the thing that if this thing's going on, or other people or themselves, what can they do to really mess this thing up? Like, are people going to be hooting and hollering? Is that going to ruin it? Like, is it more of a solemn experience? If you're busy taking photos, does that ruin it? Like, how do you mess this up? Because I swear, if we mess this up,
I'm not sure you can. I mean, when I saw the one in 2017, it turns out I thought I was going to be in a large field with a bunch of college students, but it turns out that I was on a car. We were on the road with me and my family, in the middle of nowhere. This rural road in the middle of nowhere. We just pulled aside the road, and we literally just stood in the road the whole time. It's just me and the family. I have a really hard time trying to figure out what would ruin it.
Okay. All right.
Besides clouds.
What I do think would one thing that would ruin it was not something people would do, but I wouldn't want to see it in a city. I definitely want to be somewhere with a landscape. That's the only thing I can think of. But I don't think hooping and hollering is going to change it. For me, it tends to be more of a solemn thing. But at this point, I don't.
And this one, April 8th, that we're inviting people to join us in Eagle Pass, Texas, if they don't have a better place to watch it. And I would suggest there is no better place to watch it.
It's right where it enters the United States. It's a pretty exciting place to be.
Yes. Over the Rio Grande River. It's very outside. The chances of a clear sky in April in Texas, West Texas, is really high. This is the place. And we will be there. And so people should just come. They should come to San Antonio. We'll pick them up in San Antonio if they need the ride, or if they can get themselves all the way to Eagle Pass, which is over by Del Rio and Laredo, Texas, if you know those places. That's where we're going to be. It's going to be a real winner. How long? And this is on April 8th, but we're going to do some events on the 7th, 8th, and the morning of the 9th to give people some context for this. Local townsfolks are going to join us. Maybe some school kids, Paul, are going to join us for some description before and after of what's going on. How long will this April 8th, 2024 total eclipse of the Heartland last for us? What's our experience of totality?
Total part of it, I haven't looked it up, but it's maybe 2.5, 3 minutes.
Okay.
Of totality.
That's a long time.
Yeah, the one in 2017 where I was 2 minutes and 20 seconds. I think this one's a little longer. So maybe up to 3 minutes long, but it's pretty long. But once the sun, and even after totality is over, it's still pretty cool for another 15 minutes or so. But it's not really long. It's a fairly quick event.
I don't know, 2.5 minutes of. Now, is it nighttime dark, or thank you?
Well, what it looks like, it is nighttime dark, and you can see the stars. I remember seeing Mars.
Oh wow!
In 2017, you can see the sky, but the weird thing is that it looks like there's a sunset, like the sun has gone down, and it's just about to get. It looks like twilight all the way around on the horizon, everywhere around you, not just in one part of the sky, like when the sun sets.
Wow.
So it is kind of and again, it looks like that around the horizon, but the quality of light is nothing. It cannot be reproduced. You've never. I promise you, Doug, you've never seen it before. Overall, the overall experience is not one that you've had before.
Well, and I'm very, very appreciative of your help, which will be coming on April 7th, 8th, on those days, but also your help ahead of time, because this continues to confuse me about what light is and why it operates the way it does. Because light, I mean, I feel like I know it, and then you start really thinking about it and like, okay, what is going on here? So it looks different because certain wavelengths are now being blocked by the moon. Is that what's happening? And we're seeing like why does that light change? It's to our eyes.
What we're mostly seeing is we're seeing the light produced by mostly it comes from two sources. One is just the light from anywhere around the horizon, which is fairly dim. But also it comes largely from the fact that we are receiving light from the sun's corona and not from the disk of the sun, not from what we would call the face of the sun, but from the sun's upper atmosphere, which has a different color than the face of the sun.
Why do we still get the corona? And now this is not at all related to the virus, right? No one's going to get the coronavirus.
No. Or the beer.
Well, maybe we will have a beer. We're going to be at the border of U.S. and Mexico. We will probably have a corona during the corona or just after the corona. We will introduce that. Why do we receive the corona lights and not if the moon is blocking the sun? Why do we still get that corona light from the atmosphere?
If you think of the moon as a disk and the sun as a disk, those disks are the same size. But the sun's upper atmosphere is called the corona, and it stretches out millions of miles beyond the surface, so-called, of the sun. So even when the moon blocks the disk of the sun, you can still see the corona around it.
Wow.
Does that make sense? You can still see the upper atmosphere of the sun. In other words, the entire sun's atmosphere can't be blocked by the moon, but the face of the sun can be. The disk of the sun can be.
Are we always seeing the sun's atmosphere, and we just don't notice it because we're
it's so dim compared to the face of the sun that the face of it's like hearing a whisper at a Kiss concert. You just can't.
Okay.
And this kind of leads into we have this article, 4 ways total solar eclipses helped us learn more about our universe.
Yeah, see that picture there? See, Doug, that ring of light around the sun? That's the corona.
That's the corona. So we will be seeing that.
We'll be seeing that, yes.
Okay. It won't be nighttime looking.
Right, and you can look at it with your naked eye. You can look straight at it once the disk of the sun is covered up.
Oh, but not until. Do we have to wear special glasses? Do we get to put?
Yeah, I've got some special glasses, and there's probably going to be some around there anyway. But I'll bring some, and you can look at it maybe in the last 30 seconds before totality. You can look at it without hurting your eyes, but before that, it really is risky to do.
All right. Well, that should go in the category of how do you screw this up, where you actually like burn the retina of your eyes, because it should be number 1 on our list. All right. Well, as Dan was saying, we have this article that lists these among the ways that solar eclipses have helped us understand the universe. And the first point in that article of the 4 ways is that our sun has an outer atmosphere and it's weirdly hot.
It is weirdly hot.
Now, I'll tell you, I would just expect everything to be hot, so that didn't seem to be the weird thing for me.
Oh, that part's hot too? Huh.
Yeah.
It's actually a lot. It's actually a lot hotter than the surface of the sun is.
Oh, okay.
The surface of the sun is maybe 5,800 kelvins, which is approximately 5,800 Celsius.
Yeah.
But the corona is millions of degrees. So it's super hot. It's much hotter than the surface of the sun.
Yeah. Why? Let's get into that.
It's not well understood why. magnetic in origin, but it's not clearly understood why it's so hot.
Oh,
Typically, we
okay.
think that things will get cooler the further you get from the sun, right? But it doesn't. It actually gets hotter. The corona is hotter than the surface.
Yeah. And it's millions of miles around, you said, or it expands from millions of miles?
It goes, it extends from the sun, probably 1 million miles or so. It's much, it's extensive. It's very large.
In the chat, old man Jim H says, as Paul knows, the sun is not on fire.
This is true.
What is he? Okay, because honestly, in my little, fourth grade imagination that I still carry around with me about the sun, it's a big burning gas fireball. Is that right?
It's not fire. It's not combusting. It's plasma, which is ionized gas.
Oh, okay.
Yeah, see, it's every day. I don't know a thing. Okay.
So like the gas that you're breathing now, the oxygen and nitrogen that you're breathing right now, it's not ionized. It's not hot enough to be ionized. But if you heat it up, those molecules and atoms will start to lose electrons. And that's called a plasma. Once you start losing electrons, the whole nature of the gas changes. The properties of it change very rapidly once you start ionizing the gas, and that's what a plasma is. It's an ionized gas. That's what the sun is. It's not really a fire.
There's this thing that was often said in school and continue to be repeated, that there are no dumb questions, and we all know that. It's just sometimes you ask a question and then people think you're a dumb person for asking the question, and it's never been about the question. It's always been about you. At the risk,
my experience is more often that people appreciate the person asking the question because they had the question themselves, but were too afraid to ask it.
Yes, and they didn't ask it because they didn't want to sound dumb.
Right.
So at risk that I will ask this question, and I'm not doing it to benefit anyone else. Why is the sun so hot? Like what for all these stars, what makes them start ionizing and having a plasma?
That is so far from a dumb question. That is 93 million miles away from a dumb question.
All right.
Yeah. What it basically is gravity. Because
what?
Right. That's what's holding the sun together, right? Its own gravity. That's what's holding the Earth together.
Okay.
Okay. But the sun's a lot bigger than the Earth. Okay. As you know. And so it's more dense. Basically, when you compress things, they heat up. You compress a gas, it heats up.
Okay.
Right. If you take one of those old manual bike pumps and you pump your tire full up and you feel the side of your pump, it's going to be warm because you're compressing the gas and it heats it up. That's basically what happens inside the Earth, happens inside the sun, whether it's a gas or not. When you compress things, they heat up.
Okay.
And the sun is so large, and it's got so much mass, and it squeezes itself so tight because of its gravity that the core of it gets to be tens of millions of degrees, which is hot enough to ignite nuclear fusion. So it's the sun's gravity that drives the fusion reaction and the fusion reaction makes it further heats it up.
Honestly.
So it's all driven by gravity. The whole thing is driven by gravity.
How long have we known this? How long has this been settled?
100 years, maybe 80, 90 years.
All right. So I have a piece of furniture upstairs, an old armoire made before that. When people were making that little armoire upstairs, what were they thinking was causing the sun? Did they think like I did, that it's a ball of fire?
Well, most people are not like you, Doug, and most people haven't thought about it. I haven't even asked themselves that question. But it was an open scientific question.
Okay.
because it was well understood that the sun was an enormous source of energy, and there's not like a cord, sticking off the sun you can plug into the wall. Like, where's the energy coming from? Right? It's not coming from like the outlet, like for our lamps, right?
Yeah,
That's
right.
that's where the light from our lamps comes from. You plug it in the wall, and it comes from the wall. But the sun is just sitting there with no cord, but it's this enormously bright light bulb. And scientists were really curious as to what was driving, where the energy was coming from. And it's coming from nuclear reactions that are driven by gravity. They're driven by the sun's own gravity. And so it was a unsolved question for probably centuries.
All right. So two questions I'd like to have answered. One is Peggy's question, which is, are you really live? Peggy, we are really live right now. Sometimes we trick you and we record like we did yesterday with Sarah McCammon from NPR about her book Evangelicals, and we played it live and we weren't live. I know sometimes we trick you. This time we're not tricking you. We are really live. But a great Doubting Thomas-like question. So thank you for the Easter
help my unbelief.
And it just started raining in Atlanta. That's how live we are.
And the other question is the sun anything that not anything other than gas? Like the Earth there's gas, but there's also, I don't know, like hard matter stuff,
Yeah, no, there's nothing that we would recognize as solid in the sun. It's all.
So the core of the sun that you mentioned is just what, more compressed?
It's more compressed. It's hotter. It's 12 million degrees, something like that. 15 million.
That's pretty hot.
It's pretty hot. But no, there's nothing we would recognize as solid. No, it's all just a big plasma. It's pretty dense, but it's not solid.
Wow. Okay. I mean, this just generally starts. So I guess that's why this lesson learned from an eclipse, and people could read the article if they want to get more into it, that the outer atmosphere of the sun is really, really hot, is something that was learned by an eclipse. I mean, around, the late 1800s. Does that seem right to you?
Yeah, probably about then. It was discovered that it was hot a long time ago, because you can take that light from the corona and put it through, make a spectrum out of it, and break it up into its wavelengths, like a rainbow. Okay. And by looking at that spectrum, you can determine the temperature of it.
Like a rainbow. That's so
like a rainbow.
I mean, somehow, all this confusion, then someone says like a rainbow, and doesn't your heart just open up like, oh, good. Okay. It's like a rainbow. Oh, good. There's confusion.
But yeah, that's fascinating. This is in 1869. Astronomers from Dartmouth College and Rochester University are looking at this total solar eclipse, and they use a spectroscope to split the sunlight. And they're like, oh, it's shooting out green light. And that told them the temperature of the corona. Yeah. Like, that's fascinating to me that they were doing that in 1869.
Yep. I didn't realize it was that long ago, but I'm not too surprised, because the corona is pretty bright, and they were probably, spectrographs didn't have to be that good.
And at that point, they're still not fully confident that gravity has produced all this, or were people hinting at that before we get to our second learning, which comes from Einstein? At this point, are people speculating that gravity is what's creating the nuclear?
You mean back a century and more ago?
1869. So when they point their...
they probably speculated that it was ultimately driven by gravity, but the exact mechanism was not known.
Okay.
It wasn't until we were able to, I think that people probably had the idea that nuclear reactions were possible, but not until we really got to understand them was it clear that that was the source.
And is the sun fusion or fission, or am I totally wrong on both of those?
Fusion. It takes hydrogen and converts it into helium, so it builds up larger elements from lighter ones. That's fusion. The sun does what we're trying to do. We're trying to create fusion energy on Earth. We can create fusion. We've done it, but we can't control it. The fusion that we've created basically has been in the form of bombs.
Saw that movie. Yeah.
Yeah. Although that movie Oppenheimer, the bombs they built were fission weapons, but the ones that came after in the 50s, hydrogen bombs they were called, those were fusion.
Yeah, I mean,
like
just another great example.
More powerful,
right? Yeah.
Okay, so second learning is that Einstein's gravitational deflection.
Yeah.
All right. This came from Eclipse. So if people think all these eclipses are just nothing but big media hype brought to you by Big Sun or Big Moon.
It's Big Moon trying to show how tough it is.
Like you're impressed by the sun. Wait till we step in the way. Wait till you see me now, Earth. Big Moon.
Big Sun.
They've been learning a lot from what's going on out there, up there, around there, from these eclipses. How is it, if people don't have time to read the article, because we're all busy people, that's why we're giving our time to this podcast, what did they learn in an eclipse that confirmed or pushed forward Einstein's idea of gravitational deflection?
It's basically what happens is, like, during the day, there are stars up there, but you can't see them, right? Because the sun's so bright, right?
Yeah.
So there's stars all around the sun, on all sides of the sun, in that direction. They're there. The sun's in the middle, in front of a bunch of stars. And so what happened was, when the eclipse happened, all of a sudden you could see those stars that were always there, but just that the sun washed out, right? You could see them. But they did not appear to be at the locations that they were known to be at. Because the sun's gravity deflected the starlight, and made them appear to be in different locations on the sky than they were known to be.
So they're mapping them in the normal time, then they map them when there's a total eclipse.
Right, and they're not in the same positions, because the gravity of the sun deflects them, and that deflection is normally not perceptible because the sun's so bright you can't see those stars at all.
Right. And Einstein's whole thing is that gravity is literally curving space-time.
Right.
Like it's bending things in ways. And
right. Under Newton's theory, gravity should not affect light. But under Einstein's theory, gravity should affect light.
And this solar eclipse proved it. Wow.
It did. Yeah.
Wow.
See, that made him super famous. That's what catapulted Einstein to rock star status.
Really? Yeah. This specific
he already knew
eclipse-related thing.
He'd already done calculations and compared them to some observations, but those observations were not nearly as publicly sort of good,
compelling, or
as easy to understand.
This was like a mic drop moment for him. It's like, told you.
Yeah, because bending space time super easy to understand, and just your average.
The idea of stars being in wrong locations.
Yep, fair enough.
Was let's see.
Oh, you're pulling up your screen. We can see it.
What I wanted to do was to read for you the headline, very famous, from the New York Times. This is a great headline. Okay,
it's going to be a sentence long, isn't it?
Yeah. Lights all askew in the heavens. Okay, lights all askew in the heavens, and this is the great part. Men of science more or less agog over the results of eclipse observations.
Wow.
Men of science more or less agog.
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 Great scientific term.
Yeah, more or less agog. So that's what made Einstein super famous.
That's
All right.
awesome.
We absolutely have to make T-shirts for our solar eclipse experience. More or less agog, and because that
It's a
will
great
prove
phrase.
men of science, and we are
Men of
more.
science, more or less agog.
Yeah,
That's great.
wonderful. That is a wonderful one. All right, Mike D asks a question that maybe sticks to this before we get to our third and fourth. He said, "What's the difference between gravity forming a sun from gas versus gravity forming a really, really huge planet from dust? What happens to a planet that grows really huge?" So, do you get the question?
Yeah. A planet that grew large enough would become a star.
Really?
All you need is enough mass to make it hot enough in the core to ignite fusion.
Huh.
Jupiter is basically a star that wasn't massive enough to become a star.
So depressing. I mean, don't we all feel that? Don't we all feel
so
Jupiter?
close and yet so far?
The term is actually the term is even worse. The term that's often used, it's not an official term, but it's used a lot by astronomers, is failed star.
It's great.
That's going to be on the
Yeah,
back.
so there's no difference really. It's just size. Size matters, and that's all that matters.
Wow.
Now, could Jupiter continue to grow in the coming millennia? Or is
No,
it there's
really nothing
not
to
enough
make it.
stuff
Really,
swirling around anymore?
I mean,
It's collected
it'll probably capture a few more comets and stuff like that, but it wouldn't grow enough. It would need to grow 80 times more massive than it is, approximately 80 times more massive than it is to be hot enough to become a star.
So what happens where a planet is gathering up dust and then doesn't get big enough? It ran out of dust in the proximity.
Yeah, we're living on one. Yeah.
Yeah, we just did. There just wasn't enough resources. We just it's like the perpetual. If the coach had just put me in, we would have won. And I just didn't have the time to. Where did the sun get all of its? So it was dust.
It was dust and gas, and the whole solar system formed from the same big cloud of dust and gas.
And the sun just gathered up all the gas and some dust. There's some dust in the sun, or has it all been burned away?
The dust would have been burned away and blown out by the solar wind by now. But mostly burned up. Yeah.
Not solar wind yet. All right.
Solar wind.
So back to the article of the third thing that we learned from solar eclipse eye. What is the plural of eclipse? Eclipses?
Eclipses, yeah. As nice as Eclipides. I don't know. No, it's
Eclipse eye.
Eclipses, I'm afraid. Boring.
So the article says that the headline for the thing learned was that Vulcan, the planet that never was.
Yep.
This was wonderful to me, that it did. The observations of an eclipse dispelled the idea that there was some planet that they were referring to as Vulcan, that they said, okay, now there doesn't have to be that planet there. Do I have that right? That's what happened. There was an explanation with
There was a planet. They thought there was a planet called Vulcan between Mercury and the Sun, and they named it and everything, but then they never could find it.
And this was based purely on how Mercury's orbit changed slightly. Is that right?
Right. Which was eventually shown to be a result of general relativity, Einstein's theory of gravity. But yeah, they thought that the odd motion of Mercury was caused by another planet further in.
Okay.
But it wasn't. And I can't remember what the date was. But the eclipse let them basically search the entire sky for, the sky near the sun.
Oh,
they could search it for the planet, but they couldn't find it.
Huh. And they kept not finding it. And then Einstein said,
not finding it, and they kept not finding it.
Better idea. How about if it's just gravity bending space-time? And people are like, oh, okay, yeah, that seems to make some sense.
Oh, that's it.
And the last one is that it showed us that indeed the Earth's rotation is slowing, and at some point this whole thing's going to stall out, and we're going to stop spinning.
No, we won't stop spinning.
Yeah, we'll all fly off the planet.
No, sorry to say, that as fun as that would be, it won't stop spinning altogether. But it is definitely slowing down.
And how did the eclipse show that the Earth is slowing down at this milliseconds per century or whatever the number is? Very, very slow, but noticeable.
I don't know the answer to that. I don't know what it was about, and I did not read the article because of traffic, Atlanta traffic. But I don't know what it was about the eclipse. I'm guessing because it's connected with the orbit of the moon. That they probably was a timing thing with the moon crossing the face of the sun. They were able to detect it that way. My guess is it was some kind of timing experiment.
Mm-hmm.
But yeah, the Earth is slowing down just a little bit.
But not to get alarmed. It's only 1.8 milliseconds each century that we're slowing down. So
right. The day is that much longer. So today is 1.8 milliseconds longer than than what, March 15th, 1924.
It feels that way sometimes, doesn't it? Just
yeah.
Like, are the days getting longer? I tell you what.
What's happening by a millisecond? Okay, so 4 things. The sun has an atmosphere that's wicked hot.
Yep.
Gravitational pull is what Einstein said it was, and proved this out. There was no planet, even though, as Peggy mentions in the comments, they chose to name it before they proved it. Mm-hmm. Classic. And showed that the Earth's rotation is slowing. Yep. Are we still discovering anything on this par with eclipses as they happen now? Like, will people in 2024 that someone's doing some experiment around this eclipse that's going to answer some question, or are we now all done with the benefits of eclipse and now this is just entertainment and fun?
Well, my hunch is that we're not going to do that. They're not going to learn too much new, because we have observatories in space that are always watching the sun, and that are able to basically create permanent solar eclipses. That they have a way of blocking the sun's light from the disk of the sun and looking at the corona all the time. So,
so we don't have to wait for the eclipses to happen.
Right. We basically have an eclipse happening all the time with a really good telescope looking at the sun while it's happening.
So now it's really just for fun.
It's for us little people.
This is shooting blanks at this point, where no ideas are going to be harmed in this. That's right. Nobody's pet theory, I think, is going to come crashing down. Well, good. So we can just go out and enjoy and not feel like someone's
exactly right. No pressure. You don't have to go do science, Doug. Just go and enjoy it.
Peg said, if we do end up colonizing the moon, what would happen to people on the moon during an eclipse? Is there any change to the moon itself during these eclipses, or is it just observation?
The only thing you would get from the moon is to be able to look down on the Earth and see the shadow of the moon cross the Earth.
Wow!
Oh yeah,
a little dark spot moving across the Earth at 1,000 miles an hour.
Hey, and how come this totality swath is so narrow? Is that just because of the size of the moon?
I've been teaching this stuff for so long, and I still can't get over the fact that the moon has the same size on the sky as the sun does. And it's because they're so close to being at exactly the same size. Apparently. In other words, the sun is 400 times larger than the moon.
Okay.
But it's also almost exactly 400 times further away.
Right.
So they look to to be the same size on the sky for
Wow.
us. And it's crazy that we happen to be alive. I mean, pretty much for all recorded history, it's been that way.
What?
The moon's drifting away, and so after another 100,000, 200,000 years, there'll be no more total solar eclipses.
Oh wow!
So get it while you can. Yeah. Okay.
While you can. But it's just amazing to me that the two just appear to be the same size, and that's why it happened so quickly. If the moon were a lot larger or a lot closer to the Earth, it would take a lot longer and be a lot more common.
Amazing.
It reminds me of that. Was it Apollo 13 where he does he's holding out his thumb and covers the moon, uncovers the moon. Just about distances and perception.
Yep. It's crazy.
Is that like the one people take the photo of their hand out flat and they have the Statue of Liberty sitting on their hand? Those photos.
Exactly. I am excited to see what sort of crazy pictures people take during the eclipse. It's always fun to see how people get creative with this stuff.
Yeah, and let's think all we can and set up whatever we need to set up to record or capture this with, because we will be traveling there with our Vote Common Good gear, and so we'll have some cameras and stuff, and I don't know what it should be, but it seems like we should capture something. The look on Paul's face, the tears rolling down his eyes, the solemn experience of a man having a spiritual experience. We can capture it.
I think, I had my solemn sort of intimate experience with my family for the last one. I don't care if I'm in the middle of a field with 1,000 drunk people this time. It's going to be awesome.
Okay, well, this is one. Is this the last one we're going to get unless we travel a long way? Oh, okay. Yeah. Let me ask this differently. How many times in habitable Earth a year is there a eclipse of totality?
It happens actually at least once a year somewhere.
But sometimes that's just all over ocean, because most of the
time it's at the poles. That happens at the poles, or it happens in the South Pacific.
Okay.
Or or maybe it happens. Maybe it only lasts about 10 minutes. because the shadow just is formed right before it goes off the face of the planet. So just relatively very few. Do you ever get where it's easy to get to?
Yeah, just fly into San Antonio and we pick you up and drive you out to Eagle Pass. This is easy as they come. Or for some people, just walk outside.
What I want to talk to are the people who live in the path in the city where both paths crossed, where the one from 2017 and this one somewhere in Indiana, I think, or something.
Oh, yeah, I think so.
At that point where they both cross, and all they got to do to see two solar eclipses is walk out of the front door.
Yeah.
And look up. And do honestly, it again 7 years later.
My experience in trying to talk to people about this and ask them to come join us is that, again, most people are like, I don't care. I don't care at all. Oh, yeah, that thing's happening. I don't even think I'd go outside. It's just stunning to me, Paul. Absolutely stunning. We've been plotting this since 2017. And most people are like, just, if I cared less, I wouldn't exist. That's the only way I could care any less.
Complete in my that is a complete failure of imagination.
I get that people are like, oh, I can't spend money and travel to
sure, yeah, I get
somewhere
that.
to get there, but
right,
to not be at all interested or excited about it.
About something, and the weird thing about an eclipse like this, and I felt it last time, was that this thing is happening whether or not we show up for it, and we have got to be there at this day and time, because once it's it's going to last 2 minutes, then it's going to be over, and there ain't nothing we can do to stop it. It's not like a show, or a parade that could even conceivably be stopped by any human power. This is just something that's going to happen.
Wonderful. Yeah. Well, Paul, thank you. Thank you for doing this, and we will see you April 7th and 8th in Eagle Pass, Texas, and people can go to votecommongood.com to find out all that. Thanks, everybody that's in the chat, and share it widely, and get your orders in now for my Pants Are in a Box shirts and more or less agog shirts.
Got to use that phrase.
Oh, I did hear Peggy mention something about an airplane ride during the eclipse. I saw this. I forget what airline is doing this eclipse flight where they're flying the path of totality.
Yeah.
So you can
so you
see the eclipse longer. Yeah.
It moves about 1,000 miles an hour, though, so I don't think you can get it the whole way, but you can
get a couple more minutes out of it. I don't know.
You can probably get a good 30 minutes or maybe even an hour if you're going fast enough out of it.
1,000 miles an hour. Pretty cool.
Yeah.
All right, y'all. Hey, we'll see ya.
Take care.
Bye.
Bye.